We're going to be looking at sketching these two graphs. Hopefully you've seen the previous two videos. One introducing the ideas behind sketching, and the second one doing a linear and a quadratic, and this one we've got a cubic and reciprocal to have a look at. So for all of the sketching graphs, we always start off by saying, well, let's find out where it crosses the y-axis by making x equal to 0, which in this case means we'll have y equals 0 plus 2, 0 minus 3, and 0 plus 1, which means the y-intercept is at 2 times negative 3 times 1, so negative 6. And that's where this graph will cross the y-axis. For our second point, we need to find out where across the x-axis by making y equal to 0. And because we've got it in factorised form, not too much bother to spot that the values of x that will make this equal to 0 are x equals negative 2, or x equals 3, or x equals negative 1. So that's exactly the same as solving quadratics, where these three things are multiplied together to give 0. One of them's got to be 0, and you identify the three values that will make that happen. Now, in order to find any turning points, in a lot of cases the first two skills here would be sufficient, but in order to find turning points, for this one we're going to differentiate. So before we can differentiate, I'm just going to expand the brackets. There we go, and this is now our function. So if we differentiate, we can find out the gradient function. So for this you need to be familiar with calculus, and therefore I presume doing A level. Some advanced mathematicians at GCSE will be able to do that too. And then for that to be a turning point, the maximum or a minimum, then the gradient would need to be 0. So at that point right at the top there, the gradient is 0. So if this was 0, we can see that our possible values of x would be plus or minus the square root of 7 over 3. So putting all that together, let's have a look at what that will look like. So let's put those bits together. So we've got negative 6 on the y-axis is where the graph will cross, and then we've also got 3, negative 1, and negative 2. It's a positive cubic, indicated by the fact it's just got x cubed, so it's going to go from bottom left up to top right. And that's the general shape of it. But we also know that if you take the two minimum and maximum points, the two turning points, that this one here is going to have an x coordinate of root 7 over 3, and this one down here is going to have an x coordinate of minus root 7 over 3. And if you substitute those values into the original equation up here, you can work out their equivalent y values. So that's sketching for a cubic. If we just go and do the same process for this one here, we've got x equals 0, which means that y is going to be equal to 2 over negative 3, or minus 2/3. So that's where it goes to the y-axis. For our x crossing points, but y equals 0, and then 0 equals 2 over x minus 3. Rearranging that, you'll see that there is no x-intercept, no solutions, if you like, for this particular one. So we know that it won't cross that axis. And for this one, we also need to look at impossible values. And by that I mean any values of x that just won't work. Now, because you can't divide by 0, you cannot have x equal to 3. And what that does is that gives us what is called an asymptote. And I'll show you what that looks like on the graph now. Okay, so first of all, the y-intercept is negative 2 over 3. There's an impossible value of x equals 3, so what I have to do is put in an asymptote there. That is, the equation of that is x equals 3, and what that means is that our line doesn't cross the x-axis. When x is really negative, so quite a big negative number, you'll notice it will just be a very small number, because 2 divided by a very big negative number is going to be a very small negative number, and you get this shape here. Should really go through there. And then what will happen is, as x gets really big, y will get really small. So you get that shape there, the sort of typical reciprocal graph, but it's been moved 3 to the right and squashed in by a factor of, and stretched by a factor of 2. So with your transformation of graphs, you should be familiar with that as well. The process is always the same for any graph you encounter, so just remember to do x equals 0, y equals 0, differentiate if you want to find any turning points, look out for any impossible values.